So we have 7.7. We'll be talking about base E and natural logarithms today. All right, so the first thing I want to show you guys is, well, what is E in math? E is this number right here. All right, it is a irrational number, okay? Kind of like pi. Think of this very, very similarly like pi is 3.1415, da, 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 da. Very similarly, E is just a special number that occurs a lot in the natural world, so much so that they gave it a special name and they just decided to name it E. I don't know why it's E, but it is, okay? All right, so you don't have to memorize this decimal. Just know that it's like, between 2 and 3, closer to 3, and that's fair. All right, now what you do need to know, though, is that we will be using E as the base of logs a lot. All right, E turns out to be the base of the log, like this guy right over here. And because it's used so often, they actually renamed this to be the natural log of x. All right. So log base E is the natural log, and we write it as ln. Again, I don't know why it's ln. I think it's like the reverse of natural log. So instead of NL, natural log, it's ln. Okay, so log natural. All right, so that just means the log base E. Okay, so just to kind of summarize this with our previous lesson, just know that when we have log, I'm going to do this at the very top here, log base 10 of x, we shorthand this to be just log x, no base. And when we have log base E of x, this is the natural log of x, ln. Right? And these are the only two shorthand logs. All right, so those are the only two you need to know. Maya, I'm not sure. You might want to find a calculator online that has the natural log. I don't know if the phone calculator has it. It might, if you like turn it horizontally and it has the scientific one. I think you might be able to do it. Okay. So the thing you need to know about natural log is that it is the inverse function of e to the power of x. So these guys are inverses of each other. And that's really great to know because that means they cancel each other out. So if you need to get rid of an e, you use the natural log. If you need to get rid of natural log, you use e. Okay, so they kind of cancel each other. So for example, like here, we see that we have e to the power of ln. These will cancel each other out, guys, and that will just leave you with x. Or if you look at it this way, you have natural log of e to the power of x. Those will cancel each other out and leave you with just x. All right, so that's really useful to know that these are just opposites of each other because we can do things like what we're going to do with number 1. All right, so number 1 says write an equivalent exponential or logarithmic equation. So number 1, we have an exponential equation. I'm going to write it as a log. So to get rid of that e, I am going to natural log both sides. Like this. Okay, so take the natural log of both sides, and then the natural log and e will cancel each other out. So this will be 3x is equal to natural log of 45. Okay, I'm just going to stop there. They didn't ask us to solve for x, so If I wanted to solve for x, I would divide by 3, but they're not asking me to, so I'll just go ahead and stop there. All right, number 2. I want to get rid of the log. I want to rewrite this in exponential form. So the opposite of natural log is e to the power. All right. So I'm going to take both sides and make them exponents of e. All right. I'm going to make them exponents of e. What happens then is e and the natural log will cancel out, and I'm left with just x is equal to e to the power of 8. All right, let me take a pause, see if there's any questions or clarifications. Number 3, let's go ahead and try this together. Queenie, go ahead and give this a try. What do you think we need to do for number 3?
I think we add e to both sides.
Good. Now, when you say add e, what do you mean? Like, should I add e like that, or
Oh, no, like multiply.
like multiply like that?
I think to the power.
There you go. Yes, to the power. Yes, you make those into exponents of e, right? So make them into exponents of e. So this will be e to the power of ln 4x. This will be e to the power of 9.6. Good. So now, Queenie, what happens to the e and the natural log?
They cancel each other out.
Good. And what are you left with on the left-hand side?
Just 4x.
Good. And what's on the right?
E to the 9.6 power.
Perfect. Nicely done. All right. I'm just going to pause there and stop. They didn't ask us to solve for x, so I will just go ahead and leave it like that. Yes, you can use the bathroom. Person who asked. All right, next, let's go to number 4. Let's try David. Give this one a shot. Number 4. What do you think we're going to do?
I make both sides to the natural log form.
Very good. Nice. Both sides to the natural log. Okay. And then what happens with the ln and the e?
I can cancel the L and E.
Good. The ln and the e will cancel out. Good. And what am I left with on the left-hand side?
8.2.
Perfect. Good job. Nicely done, David. And again, we're just going to leave it like that. They didn't ask us to solve for x. They just wanted to rewrite it in terms of logs. So that accomplished that. Okay. Any questions on using e and natural log to cancel each other out? Okay. All right. Let me go ahead and show you guys now how to use that to actually solve for x. We're going to jump to number 9. And oh, sorry, I see a question in the chat. How come you can just bring the power for number 4, 8.2 down? So that is the inverse property right here, right? That's how the natural log and the e cancel each other out. So we're using that inverse property for number 4. Okay, let me know if that you want more than that. I'm not sure if I can give you more, but how come the natural log on the right side doesn't go away when you take the ln away on the left-hand side? That's a great question. Yeah, the reason why the natural log on the left-hand side gets canceled out is because it gets canceled out with e. Notice on the right-hand side, there is no e to cancel out the natural log. So that's why it doesn't go away on the right-hand side, because it only cancels out with the e. Yeah. Okay, cool. Good questions. Yeah. All right, let's try number 9, and let's go ahead and try to solve for this. So number 9, I am going to try to solve for x, and I see that x is in this term right here. So I'm going to subtract the 4 first to kind of get that term all by itself on the left-hand side. Now, I need to get rid of that e, right? I'm trying to solve for x. So I'm going to get rid of that e. I'm going to natural log both sides. Okay. And what that does is it takes out the e on the left. So I'm left with x minus 2 is equal to natural log of 17. Now to solve for x, I'm going to add 2 on both sides, and I'm left with natural log of 17 plus 2. All right, guys, grab your calculators, and let's see if we can get this decimal, 4 decimal places. For natural log, it's if you have the graphing calculator like I do, it's the button to the left of the number 4. All right. Or if you know where log is, it's right underneath log. So go ahead and type in log 17 and then plus 2 and tell me what you get in the chat. 4 decimal places. Good, Faith. Good, Andrew. Good, Luke. Good, Ryan. Caitlin, I think you might have typed in the wrong number, but I think you were close. I think you had it. You might have just forgotten the number. Good, David. Good, Colby. Good, Gino. Good, Zach. Good, Michael. Good, Jamie. Good, Raheel. I think you fixed it, Caitlin. Good, Heidi. Good, Queenie. Yes, Caitlin. You got it. Good, Sophia. Nice. Good job, guys. Yep, 4.8332. Good job. You found the natural log. Nice, Gavin. Nice. Oh, question. Yes.
Do you mind going back to number 4 on the right and equivalent?
Sure. No problem.
Yeah.
There you go.
Thank you. Oh, okay. I put 10x instead of ln 10x.
Oh, yes. Very important to know that. Yes. All right. Cool. Let's go to number 10. So far, so good, guys. Nice. All right, so number 10. Again, I need to solve for x. So I'm going to get this term with x all by itself by adding 5 on both sides. So I'm going to add 5. And I get natural log of x plus 3 is equal to positive 3. Now, to get rid of the natural log, I'm going to do the opposite, which is e to the power, right? E to the power. Oh, if you're lazy, I have a little trick for you. You can, instead of rewriting the whole thing, you can write a really big E like that and make those exponents like that. All right, so you can do that. Or if you're like, nope, that makes my notes look really ugly, you can feel free to rewrite it and do E to the power of each. So up to you. Either one I'm okay with. All right, and the e and the natural log will cancel out, leaving you with x plus 3 is equal to e to the third. Subtract 3. And let's go to our calculators again. All right, good, nice, Andrew. Good, Faith. To get to the e to the power, guys, press the blue button and then the natural log button. Blue button, natural log button. All right, and that's how you get e to the power. And then make sure you do subtract 3 at the end. All right, good, Andrew, good, Faith, good, Luke, nice. Good, Jamie, good, Gino, good, Zach, good, Mason, good, Michael, good, Gio, good, Raheel, good, David, good, Maddie, good, Colby, good, Sophia. Nice, good job, guys. How do I do it with the Desmos? I don't know. I think you'll have to kind of play around with that. I think there's like a little keyboard button on the bottom left of Desmos. You probably have to click that and then look for the e to the power. All right, and that is how you guys solve with these. Okay, cool. Any questions? All right, if you need help with the Desmos calculator, maybe after class, I can show you where that is. But I'm pretty sure it's on the bottom left in that keyboard. Okay, let's go back to 5 through 8. Okay, now 5 through 8, I just want to show you guys how basically natural logs work exactly the same as logs. Okay, there's nothing different. It's just one less letter, but it is a log still. So properties we used before with logs, we can use with natural logs. So for example, number 5, if I want to write this as a single log, I'm going to bring this 3 up as the exponent. All right, that was the third property we learned with logs. And then this is going to be a natural log of 27. To combine this, because it's subtraction, I'm going to divide. So I have natural log of 27 divided by 9. And that gets me natural log of 3. Okay, so that's just to show you guys. Again, it's pretty much the same thing with logs. Okay, because of time, I'm going to skip number 6 because it's pretty much the same as number 5. Let's go straight to number 7. Help me out with this one, actually. Let me ask Ryan. Ryan, can you help me out with number 7? What do you think we can do?
So would you bring the 2 on the x? Yeah, 2 on the x.
So tell me what to write.
So ln x to the second power.
Good. Keep going.
And then you do the same thing on the other one, so it'd be 4 to the second power.
Good.
So ln 4 to the second power.
Which is?
16.
Perfect. All right. And then I want to combine this still into one natural log. So what do I do with that?
Is it x squared times 16?
Perfect. Good. So natural log of then 16x squared. Nicely done. All right. And that's it. Yes, you can use the bathroom. All right. Number 8. Let's try this one more time. Let's go to Geo. Try this one out.
Okay, so you would do ln 4 to the power of 3 on the first one,
Nice.
and then you would do ln 3 to the power of 3, but add, yeah.
Good. Nice. Keep going.
And then 4 to the power of 3 is 64, and 3 to the power of 3 is 27, so you can multiply those two.
Good. And that I do not know. Calculator. All right. So natural log of, what did you say you would do with the 64 and 27?
You multiply them.
Good. All right. So I get 1728 as that final answer. Good. Nicely done. Okay. So hopefully you guys can see that, again, all those properties still apply with those natural logs. Okay. All right. Awesome. Let's go ahead and go backwards with number 14 and 15. Told you I was going to jump around. Same properties, but basically instead of going from a single log, we're going to separate them, all right, into many logs. So for example, number 14, this is multiplying. So to separate it, I'm going to use addition. So this is natural log of 12 plus natural log of x squared. And then I'm going to bring down the exponent, natural log of 12 plus 2 natural log of x. All right. So same properties, opposite direction. All right, number 15, very similar. It looks a little complicated, but if I rewrite this as an exponent, it's not so bad. So the fifth root of x cubed is just x to the 3 over 5. Bring down the exponent, and I get 3 over 5 natural log of x. All right, I just realized I did all those problems. So do you guys have any questions about going in this direction? All right, doing pretty good on time. So let's focus up now on number 11 and 12. All right, 11 and 12, very similar to number 9 and 10. All right, the only difference is inequalities. And you do the exact same thing, except you just are careful about the less than or greater than sign, especially when you divide by a negative. You gotta flip it, okay? All right, so let's try it. Number 11. Help me out with this one. Let me call on Maddie. All right, Maddie, what do you think?
Isn't the first thing you're supposed to do is put it into like ln?
Good. So tell me what to write.
ln e,
Huh?
and then to the power of negative 8x, and then for the other side, when it would be inequality, then ln 50.
Perfect. Nicely done. Nicely done. All right, because our goal is to get rid of the e. So natural logging both sides gets rid of the e with the natural log, and that leaves us with negative 8x less than or equal to natural log of 50. All right, and Maddie, we're actually almost done, so finish it off. What do we do after this?
You divide by negative 8, which would flip the sign.
Good, nicely done. Flip the sign, and natural log of 50 divided by 8. Gotta do on our calculators. And hopefully you guys are all seeing this decimal. All right, nicely done, Maddie. Okay, let me see if there's any questions in the chat. No? Okay. Awesome. Okay, let's try number 12. Ooh, number 12's a little more difficult because the x is inside a log. Now remember, guys, we have some restrictions about what can go inside logs, right? I know that 5x, this guy, has to be greater than 0. Okay, so that's number 1. Also, 3x has to be greater than 0. Okay, and then we actually have to solve the problem itself. Okay, so hopefully that looks familiar from what we've done before. Divide by 5, I get x is greater than 0. Divide by 3, I get x is greater than 0. Okay, so x has to be positive. So that's good to know. So let's actually solve for this. First, let's combine these to be one log. Let me ask somebody. Help me combine those into one log. Faith, what do you think? What do I do to combine those?
You have to multiply them
Yeah.
together since you're adding.
So what do I get?
15x squared.
Nice. All right. And then what do I do to get rid of that? Thank you, Faith. What do I do to get rid of that natural log? Sophia, how do I get rid of that natural log?
Don't you like raise it to the or put an e so that it cancels out?
Good. Nice. So e to the power and they cancel out. Good. So Sophia, what am I left with here?
Then you just have 15x squared is greater than e to the 9 power.
Nicely done. Awesome. Good job, guys. All right, that really is the hardest part. So now we just solve for x. We divide by 15. All right, and then here, this gets a little tricky actually. I'm going to square root both sides. Now, with an inequality, when you square root both sides like that, that means x is going to be greater than the positive, or x can be less than the negative of that whole nasty looking thing. Okay? So if you're like, wait a second, what? Think about like when you do x squared is greater than 4, for example. When you square root both sides, it's not just x is greater than 2, x can be less than negative 2. It can be one or the other. Okay? So type that into your calculator. Sorry, I'm gonna just go ahead and speed through this calculator part. Let me know if you're not getting it though, and I can definitely show you. But I get 23.2423. All right, so technically those would be my right answers, except remember, x has to be greater than 0. So I actually can throw this whole part out and just have this as my final answer. Okay, because x had to be greater than 0, can't be negative, so that would be my final answer. Okay, I know that was a lot, so let me pause and see if there's any questions on that. All right. Well, let's finish this off then, guys. So last thing I want to show you is number 16 and 17. And I mean, if there's time, we'll go back for the word problem. But 16 and 17, I just want to show you guys that you can use natural logs to solve for equations like this too. What you guys have done before is you've just logged both sides like that, brought down the x, and then divided by log 8, like that. Okay, and now I just want to show you guys that you can do the exact same thing with the natural log. All right, the only difference is you have one less letter to write each time. Instead of 3 letters, you have 2. All right, so you can natural log both sides like that. Bring down the x. And then divide by the natural log. So you can see how it's like the exact same thing, right? It's just natural log. But what's cool is in the end, you actually get the exact same answer of x is equal to 1.5283. Either way. All right, so it's really up to you which one you want to use. Okay, so why don't you guys try it? Number 17, go ahead and try it, and then type your answer into the chat and let me know what you get. And there is the answer for number 17, 1.3900. Just be a little careful with the rounding. Yeah, no worries. I think you got the hard stuff down, so just make sure you're careful at the very end too. Okay? All right. Very nice. Any other questions? Let me see. Okay. Any questions on that? I don't see any in the chat. Okay. All right, let me just really quickly show number 13 since we do have just a couple minutes left. All right, so number 13, Sarita. Sarita? I do not know. Deposits $1,000 in an account paying 3.4% annual interest compounded continuously. That's nice. All right, use the formula for continuously compounded interest. So they give us the formula where P is the principal, R is the interest rate, and T is the time in years. What is Sarita's balance after 5 years? All right, so they want to know what is the balance. So I'm looking for A. All right, and so I'm looking for A. P is the starting amount. That's 1,000. E is E. R is this rate, but I need to put it into decimal form. So that's 0.034. All right, so 0.034 after 5 years. Plug that into your calculator and you would get this much money. That looks nice. All right. And then part B, how long will it take the balance in Sarita's account to reach 2,000? All right, so they're asking how long. So that means I'm looking for T. So I want to see how long will it take to reach 2,000 at the same interest rate. So I'm looking for T. I'm going to divide both sides by 1,000. And I get 2. Now to get rid of the E, I'm going to natural log both sides. And that gets rid of that. And so I get natural log of 2 is equal to 0.034t. Divide by 0.034. And that gets you about 20 years, approximately. All right, whew, squeeze that one in. All right, good job, guys. Thank you. Stick around if you have questions. If not, good luck on homework, and I'll see you guys tomorrow.